Greetings and welcome. In this video session, we will see a procedure to solve a numerical in order to calculate coefficient of lift, coefficient of drag of a kite flying in wind. Let us see the statement of the numerical. A kite has plan area of 0.25 meters square and is flying in a wind of velocity 25 km per hour. The kite has net weight of 1.2 Newton. When string is inclined at an angle of 15 degree to the vertical. Tension in string was found to be 3 Newton. Take density of air as 1.15 kilogram per meter cube. Calculate the coefficient of lift and drag. So the said situation is shown here with the help of a diagram. Here this is a kite which is in the air in inclined fashion. This is a string tension line. Angle made by this string tension line with vertical, that is a theta. On the kite, application of force Fd, that is horizontal force. Fl, that is a vertical force. Weight, which is acting in a downward direction, that is a W. And this is a speed, U. Area of this kite, that is a projected area, A. From the statement, the values are mentioned over here under the title given data. So area in meter square, speed in kmph, weight of the kite in Newton, string tension in Newton, string angle to vertical in degree, and density in kg per meter cube. First, we have to calculate the wind velocity in meter per second because speed is given in kmph. So we convert that by multiplying 25 into 1000 divided by 60 into 60. Conversion by using 1000 multiply, that is a conversion from kilometer to meter, and 60 by 60, this at a denominator, that is conversion from hour to second. So we find the answer in meter per second of wind velocity. Area of kite in meter square is given. In order to calculate coefficient of drag, that is the value of CD, let us use the force diagram. So here this is a kite. On the kite, this is a weight which is acting in a downward direction. Lift force, upward direction. Then this is a drag force which is acting in horizontal way. And this is a string tension component. Now this string tension component, T, that component is resolved into two components. One is a horizontal component, angle made by the string, that is given with the vertical theta. So remaining angle will be what? 90 minus theta. So adjacent component of this T with the horizontal will be what? Cos ratio. That is why we take T cos of this angle, 90 minus theta. Then vertical component, for that we take into consideration this angle. So adjacent angle is theta. That is why this resolved component, vertical component will be what? T cos theta. These are the components which are of string tension. Now, in order to calculate the coefficient of drag, we use balancing of horizontal forces because we are concerned with drag force. So that is why drag force, for that we will take horizontal forces. So we get for the drag force Fd is equal to, this is Fd, and in opposite direction this is a force T cos of 90 minus theta. We will say this as a equation number A. From the theory we know Fd is equal to half into CD rho A capital U square, say equation B. If you observe A and B, left side is the same. So we can equate right side of the equation A and B. Thus, we write this quantity here, left side of the equality side. We write this quantity here on the right side of the equality side. And this equation we solve. So putting the values in this equation, value of string tension in a Newton, cos 90 minus value of theta is a given, is equal to CD, we have to calculate, multiplied by half into value of rho, density of air, into value of area, projected area, multiplied by calculated value of velocity in meter per second. So in this equation, by solving this, we get the answer of coefficient of drag. The next calculation is of coefficient of lift. So for that we have to take into consideration forces along the vertical line. So for that, this is a diagram we will use. In this case, we see the lift force which is acting in upward direction. We will take it as a positive sign. And this is a force which is acting in a downward direction, T cos theta. So from the force diagram, using summation of vertical forces means sigma Fy is equal to 0, we will use the sign convention for upward forces positive, downward forces negative. In this case, first lift force is upward, that is why positive. Then the force component means weight component is acting in a downward direction, so minus W. And then the string component, vertical component of the string tension, that is a T cos theta, which is in downward direction, that is why we have taken here with minus sign, is equal to 0. Then we know that from the theory, FL, that is a lift force, is equal to CL into half rho A capital U square. So now we put this expression of FL at the place of this FL. So here we find this CL half rho A capital U square minus W minus T cos theta is equal to 0. We say this equation as a equation number 2. Then putting values in this equation, CL is an unknown, into half into value of density of air, value of projected area, value of speed. Then weight of kite is given in Newton, string tension is given in Newton, cos of angle is given with a vertical. Putting all those values, doing the calculation, we get the answer for the coefficient of lift of the kite. So in this numerical, we have seen a procedure to find the coefficient of lift and coefficient of drag for the kite which is flying in the wind of air. Let us meet in the next video session. Thank you.